Hello everyone. Let us solve today's 5 questions. First question is, the optical fiber works on the principle of scattering of light, diffraction of light, total internal reflection of light, and dispersion of light. So first question, as we have already discussed, optical fibers, they are based on total internal reflection of light. So here question number 1, option C is correct. And next is question number 2 is, the basic reason for the extraordinary sparkle of suitably cut diamond is that first option is it has low refractive index, second it has high transparency, third it has high refractive index, and it is very hard. So question number 2, here you see sparkling of the diamond depends upon total internal reflection because light get trapped inside the diamond, and that is why it would start sparkling because large amount of light would get entrapped in it. Now you see what's the reason behind that. Here option C is correct because it has high refractive index. If it is high refractive index, its critical angle would be less, and generally all the angles of incidences would be greater than critical angle, and total internal reflection would take place inside the diamond, and light would get easily trapped inside the diamond. So option number C is correct. Diamond has very high refractive index. Third question is assertion reasoning question. Question number 3, it is assertion is a convex mirror cannot form a real image. We know that convex mirror is a diverging mirror. So whenever the ray of light falls on it, every time it would diverge the rays. So wherever be the position of the object, the image would always be behind the mirror, diminished in size and erect. So convex mirror can never make the real images, it always make the virtual image. So assertion is what then? Convex mirror cannot form the real image. So assertion here is true. And now let us see reason. Reason says convex mirror converges the parallel rays that are incident on it. Convex, here also I have drawn the diagram. When the parallel beam of light falls on the convex mirror, it is not going to converge them. Here divergence of the rays is taking place when parallel beam of light is falling on the convex mirror. So here we can say that here a reason is wrong or reason is false. So accordingly we can choose the option. Question number 4 is, explain briefly how the focal length of the convex lens changes with increase in wavelength of incident light. So focal length and wavelength of incident light, we have to find out the relation. As according to lens maker's formula, we know that 1 over f is equal to refractive index of the lens with respect to the medium minus 1 over r1 minus 1 over r2. So this is the lens maker's formula. So using this formula, we can find the relation between the wavelength and focal length. Now you see refractive index of the medium, if this lens is placed in some medium, refractive index of the lens depends inversely on the velocity of the light in that medium, and velocity is directly proportional to lambda, so we can say that refractive index is inversely proportional to wavelength. Now if the wavelength is being increased here, see question number 4, wavelength is increased. So if the wavelength is increased, then refractive index would be decreased, and if refractive index is decreasing here, wavelength, this focal length would get increased because there is a inverse relation between the two. So if refractive index of the lens is decreasing, focal length, this is 1 over f here, it would increase. So we would write focal length of lens will increase. Next is question number 5. Fifth question is, a convex lens made up of glass of refractive index 1.5 is dipped in turn in first a medium of refractive index 1.65, second a medium of refractive index 1.33. What will it behave as converging or diverging lens in the two cases? Here today in the class also we have discussed the relationship between the refractive indices of the lens and the medium in which it is placed. So here what are the things which are given? Refractive index of the lens is 1.5 and refractive indices of the two mediums in which the lens is dipped is given as, first case, refractive index of the medium number 1 is 1.65 and of the second medium number 2, it is 1.33. So these are the two refractive indices which are given in which the lens is being dipped. Now first case is, we have to see the behavior of the lens, whether it is behaving as a converging lens or diverging lens. So we can use the lens maker's formula, and in second part we have to find out the change in the focal length. So here first, as change, also we have to find out how the focal length is going to be affected when the lens is being placed inside the mediums. So using the lens maker's formula, it is 1 over f is equal to refractive index of the lens with respect to the medium minus 1 over r1 minus 1 by r2. Now if you will, as we have to find out the change in focal length, so let's find out the focal length in air first. 1 over f in air, what is the focal length? So here what I would write, refractive index of the lens, refractive index of the air minus 1 over r1 minus 1 by r2. So these values are not given, so we have to just make the comparison between the focal lengths. So here it is 1.5 over 1 minus 1 over r1 minus 1 by r2, and this can be written as 1.5 minus 1, it's 0.5, 1 by r1 minus 1 by r2. So this is the expression for the focal length in air. Now let us dip this lens in a liquid number 1, that is 1 point, whose refractive index is 1.65. So let us write this focal length is 1 in medium number 1. So this would become refractive index of the lens over refractive index of the medium 1 minus 1 over r1 minus 1 by r2. Substituting the values, it is 1.5 over 1.65 minus 1 over r1 minus 1 by r2, and this would become, it is 0.9 minus 1 over r1 minus 1 by r2, and this, you see, 0.9 minus 1, it's minus 0.1 over r1 minus 1 by r2. So you see here the focal length becomes negative, f1 is negative. So when the focal length is negative, lens would behave as a diverging lens. Lens will behave as diverging lens. Now if you want to make the comparison between the two focal lengths, so you can divide these two focal lengths, focal length of lens in air and focal length of the lens in the medium number 1. So here it is 0.5 and here it is 0.1. So if you will take the ratio of these two, 1 over FA over 1 over F1. FA was 0.5, 1 over R1 minus 1 by R2, and 1 over F1 is minus 0.1, 1 over R1 minus 1 by R2. So what will you get here? F1 over Fa is equal to 0.5. So F1 would become 0.5 times Fa. So this is a relation ki what the focal length of the lens was in air when it is dipped in the liquid. I'm taking magnitude minus sign. We have already signified, written the significance of minus sign, that it would start behaving as a diverging lens. But the focal length, you see, focal length is also going to be affected here. It would become 0.5 times the 0.5 over 0.1 is also there. So 0.1, because this term is going to get cancelled, 0.1 is there, so this would become 5 times Fa. So focal length of the lens would become 5 times the focal length of the lens in air when it is dipped in the water. So this is a change in the focal length. Now second part also we can derive. Now let's find out the focal length of the lens in the second medium. Now for second medium, refractive index is given as 1.33. So using the lens maker's formula, let us consider the focal length in the second medium is f2. So this would become refractive index of the lens over refractive index of the medium 2 minus 1 by R1 minus 1 by R2. So here this is 1.5, this is given as 1.33 minus 1 over R1 minus 1 by R2. So simplifying this, 1.5 over 1.33 is approx 1.13 minus 1 over R1 minus 1 by R2, and this is 0.13 times 1 over R1 minus 1 by R2. Now when we are going to compare this focal length with the focal length when the lens was placed in the air, so that is given as 0.5 times 1 over R1 minus 1 by R2. And one more thing here, you see the focal length is coming to be positive. So as focal length is positive here, because this term is positive, this term is already positive for the convex lens, so this f is positive, so here the lens will behave as converging lens. Now let's find out how this focal length is going to be affected, again taking the ratio. So this was f2, 1 over fa over 1 over f2. This was 0.5, 1 over R1 minus 1 by R2, and this is 0.13, 1 over R1 minus 1 by R2. So this is going to get cancelled. So f2 over fa is 0.5 over 0.13. So here f2 is, this would be approximately 3.85 fa. So focal length in the liquid 2 would become 3.85 times the focal length of the lens in the air. Now you can see here the focal length in both of the mediums, it's going to be increased. So in the first case it was becoming 5 times the focal length in the air, and here it is becoming 3.85 times the focal length of the lens in the air. So this is the change in the focal length, and here we have written the behavior of the lenses when they are dipped in the liquid number 1 and liquid number 2. So generalized conclusion is what? That whenever the refractive index of the lens is more than the refractive index of the medium, then the behavior would be normal. Convex lens would be behaving as converging, and concave lens would be behaving as diverging lens. But if the reverse is there, means if the refractive index of the lens is less than the medium in which it is placed, then opposite behavior is shown. Convex would become diverging lens and concave would become converging lens. So that's all for today. Thank you.